Hello students, in today's video we're going to talk about finding the limits involving infinity. So what I'd like for you to do is pause your screen, try solving this quick warm-up problem, and we'll solve it together in just a second. Hopefully you paused your screen and you're coming back now to check the answers. So in this question they're asking you to identify all asymptotes of the graph of 1 divided by x. Now, first thing we want to do is start by finding the vertical asymptote. Now, in order for us to find the vertical asymptote of any function, we need to solve the denominator for 0. Or for 0, or to find out what x is equal to. So, what we're going to do is we're going to take the denominator and set it equal to 0. So the denominator is x, so we're going to set that equal to 0. And that's our vertical asymptote. So what we could do now is we can draw a vertical line at x equals 0 and draw the graph around that. So this is one of those graphs where you really should just memorize what it looks like because it's going to come up over and over and over again. So when we draw that graph, it should look just like this. Now notice as it gets closer and closer to 0 from the negative side, it goes towards negative infinity. And the right side of the graph looks like so. So as x approaches 0 from the positive side, you'll notice that it's approaching positive infinity. So those are our asymptotes. If we wanted to go a little further, we can find a vertical asymptote, or a horizontal asymptote, and that's at x equals 0. But we'll talk about that more in the next slide or two. So again, we're trying to find limits involving infinity. And so whenever we're trying to find limits involving infinity, these are just the two most basic. It means that the limit as x approaches infinity for 1 divided by x is equal to 0. And the bottom says the limit as x approaches negative infinity for 1 divided by x is equal to 0. So if we take a look at the sketch that we created earlier, you'll notice that as x approaches infinity, which means as we go to the right, you'll notice that the graph gets closer and closer and closer to 0. It'll never ever be at 0, but it'll get very close. And as we go towards negative infinity here, for the bottom example, it's continuing to go towards 0 as well. So let's talk about horizontal asymptotes. Now finding horizontal asymptotes, the exact definition is the line y equals b is a horizontal asymptote if the limit as x approaches infinity for f of x is equal to b, or the limit as x approaches negative infinity of f of x is equal to b. So let's look at an example for that. So here we have this function that you can see here. It's asking us to find the limit as x approaches infinity, as x approaches negative infinity, and part C is to identify all horizontal asymptotes. So that's what we're going to do. Now, we can graph this, but I want us to slowly get away from using the calculator because 1, it slows us down, and 2, you really should start learning how these work. Now, if we look at the function itself, you'll notice that we have these two constants at the end. We have the -1 and we have the -3. So what we want to do there is notice that as x gets closer and closer and closer to infinity, means it's going to get larger and larger and larger. If let's say we had 2,000, subtracting 1 isn't going to do too much difference. So what we could really do is just focus on 2x and the absolute value of x. Now, as we get closer to infinity, you can imagine that 2x, let's say we say x is equal to 10,000, and the denominator, the absolute value of 10,000, we already know is going to be 10,000. But if we were to divide these, you'll notice that the 10,000s just cancel out, which means the limit as x approaches infinity, because x is going to continue to get larger than 10,000, no matter what is going to get canceled out. So the limit as x approaches infinity for f of x is 2. Now let's look at the same problem, but this time we are going to look at if we had changed the x value from 10,000 to negative 10,000. So what's going to happen here is our 10,000s are going to cancel out. You'll notice that the absolute value of a negative will still be positive. So really you're looking at 2 times 1, because 10,000 divided by 10,000 is 1. But the 10,000 on the numerator had a negative, so this is going to be negative 2. Therefore, the limit as x approaches from the negative side is equal to negative 2. So, if we were to draw our asymptotes, our horizontal asymptotes, they would be at 2 and negative 2, like so. Now, because you're all overachievers, we're going to find the vertical asymptotes really quick. I know that our horizontal asymptotes shifted. We'll fix them in a second. So if we solve the denominator for 0, we'll find that x equals 3 and x equals negative 3. That means we can draw another set of horizontal asymptotes at 3 and negative 3. So our final graph, especially on the outskirts, are very similar to 1 divided by x. They will look like, actually I already created it. They will look like the following graph, which I'm going to uncover, which looks like this. So you notice our horizontal asymptotes, they're all approaching 2 and negative 2 and 3, which is right here, and positive 3. You'll notice the middle graph, it intercepts the asymptotes. It's not supposed to, but horizontal asymptotes can be crossed, and that's what you're seeing here. So let's look at the next example. Here we're trying to find vertical asymptotes. We talked about that, but the definition states that the limit as x approaches a from the positive side for f of x is equal to positive infinity or negative infinity. We'll show you some examples of that now. And now, so for part A, it says find the vertical asymptotes. And that's just what we're going to do. So we have the numerator, which I just rewrote, and the denominator I'm going to factor out already, which becomes what you see in front of you now. So we factored out the denominator, and if we wanted to find the vertical asymptote, we solve for the denominator. So x is equal to 3 halves, and x is equal to negative 1. So now we found our vertical asymptotes. So if we sketch those vertical asymptotes at 3 halves, or 1.5, and at negative 1, our function, our graphs, will revolve around these two things. Now, if you look at the function again, which I'm putting a small rectangle around, if we were to let x be equal to infinity, looking at our x values only, you'll notice that it has negative x divided by 2x squared. Now, because there's an x squared on the denominator, we can redo that. So notice what I'm doing is I'm giving you another option for looking at horizontal asymptotes. So if we simplified our x's, we have negative 1 divided by 2x. You'll notice here that as x approaches infinity, this is going to get closer and closer and closer to 0. So we're going to go ahead and sketch that. And now our graph. Our graph, which I also showed or created already, will look like the following. You'll notice it matches all of our asymptotes, and it looks very similar to the 1 divided by x, but because there's two asymptotes, we have that central line in the middle, which looks like a cubic graph. So the properties of the limits as x approaches positive and negative infinity are the same as the ones that I showed you on the table from yesterday. The ones where you take the limits of two functions and you can add them, subtract them, multiply, divide, or even raise them to a power. So let's do a quick example of how to find the limit as x approaches infinity. So we're going to do here is find the limit. We're going to separate these. The limit for 1 divided by x as x approaches infinity. I'm going to put INF for infinity. All of this is going to be multiplied to the limit for sine x as x approaches infinity there. Now, this is another moment where we can bring in the squeeze theorem, but I'm just going to explain it to you because I think it'll make more sense. Now, if we looked at these two functions, we know that as x approaches infinity, this number is going to get larger and larger and larger. For example, 1 divided by 1,000, or 1 divided by 10,000, 1 divided by 1,000,000. And you'll notice as x approaches infinity for this function, we know that that limit is going to get closer and closer and closer to 0. And so we're going to multiply that to the function as x approaches infinity for sine x. Now we know that sine x is a graph that is cyclical. It's going to fluctuate between -1 and +1. Now keeping in mind that 0 times anything is 0, this limit for this function will always be equal to 0 because 0 times -1 is 0 and 0 times 1 is 0. So now you have your limit. So please make sure you write down any questions or be ready to ask questions as soon as we get back to class. That's all for now. I'll see you guys next time.